Okay, so in this lesson, we're going to discuss negative exponents. And here's what I mean. Let's say we have 5 to the negative 2, okay? Whenever you have a negative exponent, you're just going to flip the number around. And here's what I mean. This is equal to 1 over 5 squared, okay? And once you know that, then we have 1 over 5 squared, which is 25, okay? Keep in mind that this 5 to the negative 2 is also 5 to the negative 2 over 1, okay? We don't write the 1 underneath because it's assumed that there's a 1. But if you write it out, you'll see that all we're doing is we are flipping, okay? Meaning that we're taking this fraction and we're going to rotate it along the axis of the fraction. So it's going to rotate this way. Okay, so when you rotate that, the bottom becomes the top and the top becomes the bottom. In other words, whatever's in the numerator becomes the denominator. Okay, right here. Whatever's in the numerator becomes the denominator, and whatever's in the denominator becomes the numerator. Okay, so whenever you see a negative, you flip it around, and then the power becomes positive. So here's another example. Let's say it's 6 to the negative 3. Okay, that is the same. Okay, remember 6 to the negative 3 actually has a 1 underneath. So now we're going to make this 1 over 6 to the, now it's a positive power. Okay, and that is equal to 1 times 6 times 6 times 6. Okay, and 6 times 6 is 36 times another 6 is 216. Okay, so let's take a look at another example. What happens if it's the other way around? What I mean by that? What happens if you've got this? 1 over x to the negative 2. Okay, well, we follow the same rule. Whenever you have a negative power, you're going to flip the fraction around. So now the x to the negative 2 becomes the numerator, and the power is now positive, and the 1 goes down to the bottom. Okay? And since we don't really need the 1, the answer becomes x squared. Okay? Let's add a couple more components to this. What happens if we have a problem like this? X to the negative 2 over y to the negative 3. Okay? No different. We're going to flip the fraction around so that the denominator becomes the numerator becomes the denominator. Okay? So if we were to write this, we now have y to the positive 3, right? Because now it's becoming the numerator, and x goes to the denominator, and it becomes a positive 2. Okay, so you notice how we flipped it around, and as we flip, the powers become positive. It's no longer negative. Okay, so now you understand the whole flipping concept. Fairly straightforward, right? But what do we do after that if there's more to work with? Let me give you an example. Let's say you have x to the negative 2 divided by x to the third. Well, we could flip just one of them, okay? And let me show you what I mean, and then I will show you how or why. So this can actually become 1 over x squared, x cubed, okay? You notice that the x to the negative 2 was the only thing that moved, and it went to the denominator, okay? This is the only thing that moved. It only went down here. You notice that the x cubed didn't move. And so when there's nothing left in the numerator, we still need to put a 1 there because you need to express it as a fraction. Okay? So once you have this, then we know that this is 1 over x times x, right? Times x times x times x, which is equal to 1 over x to the, how many x's are there? 1, 2, 3, 4, 5. 1 to the x to the 5th. Okay? Now, here's the question. Why can you do that? Or, Mr. Chang, how did you do that? Okay? Here's what I mean. Let's take that same problem and we're going to rewrite it. This is equal to, okay, x to the negative 2 over 1 times 1 over x to the 3. Okay, I'm going to pause here for a few seconds and let you absorb this. So all we did was we broke up the fraction, but it's still equal. Okay, we just put each individual term on its own. So now that you understand that, hopefully, you can see why we can just flip one of the term, right? So this is the term. This is the term that we're going to flip, right? So now this becomes 1 over x squared. Okay, see that? We just flip this thing down to here. Okay, and then move this up to here. Then we're going to continue on with the problem. Times 1 over x cubed. Okay, so now that becomes 1 over x squared x cubed. Okay, which now we're going to continue on like the first example. This becomes 1 over x times x times x times x times x. Okay, that is 1 over x to the, how many x's are there? 1, 2, 3, 4, 5. 1 over x to the 5th power. Okay? Hopefully this is making some sense to you. We're going to add to the complexity now. Let's look at another example. Let's say we have x to the negative 3, y to the second, z to the negative 4 over 2, y to the negative 2, z to the negative 3. Okay, so we're going to be moving a lot of components around. So wherever there's a negative, okay, a negative power, we're going to move either up or down. So if it's at the top, we're going to move it down. If it's at the bottom, we're going to move it to the top. Okay, so follow carefully. We know that x to the negative 3 has to go down to the bottom, so we're not going to write that in the numerator. We also know that y squared is a positive power, so that stays in the numerator. Okay, z to the negative 4 is a negative power, so that's going to come down to the bottom, to the denominator. Okay, so we said that x to the negative 3 goes to the bottom, so we know it goes here. Okay, we also know that z to the negative 4 moves down to the bottom, so that comes here. Okay, now let's look at the denominator. The number 2 is raised to the power of 1. We don't write it, but it's raised to the power of 1, and it's a positive, so the 2 stays down in the denominator. Okay, y to the negative 2 actually moves up to the numerator. So we're going to write that here, y to the power 2 again. Okay, z to the negative 3 actually moves up to the numerator. So we write z to the 3. And actually, this z to the negative 4 is incorrectly written because we moved it from the top to the bottom. So that should be a positive. Okay, so we're going to erase that. Rewrite that to z to the 4th. Okay, so now I'm going to rewrite this so it's a little cleaner. Y squared, z cubed over 2x cubed, z to the 4th. Okay, so to simplify this, we know that y squared times y squared is y to the 4th. Okay, what do we do with the z? Well, let's think about this. We're going to multiply the z out. So this is times z times z times z. Okay, we're going to just leave it at that for now. Down in the denominator, we have 2x cubed, but then we have z to the 4th. Let's write that out too. Z times z times z times z. Oh, look at that. We have 3 z's up top and 4 z's down in the bottom, so these can cancel out. Cancel out, cancel out, cancel out. So we're left with 1 z in the bottom. So now that equals y to the 4th over 2x cubed z. Okay, so was that a little confusing? Maybe. I'm going to do that problem again. However, I'm going to color code this so that it's a little bit easier to see. Okay, so I'm going to rewrite this. So let's say that we have our x's represented by blue. So we're going to write x to the negative 3. Y, we're going to represent it by red, y to the 2, and z in green. Okay, we're doing the same exact problem as before. And that was over 2. We're going to represent that in black. Y to the negative 2, and z to the negative 3. So hopefully this color coding will help you to see the movement of each of the components. So I'm going to rewrite this, and now that is equal to y squared, z cubed over 2 x cubed z to the 4th. Okay? Now, take a look at this. See where the movements took place. Hopefully the coloring helps you to see what happened. Okay? If you still don't see it, pause this video for a minute until you get it. If you do get it, then let's move on. So now that equals y to the 4th, because y squared times y squared is y to the 4th. Okay? And then down at the bottom, we have 2 x cubed, and the z's cancel out at the top. So now we're left with a z at the bottom. Okay? So hopefully that made sense to you. Again, as usual, if any of this was confusing, please go back to the beginning of this recording and go step by step until you understand. And hopefully this will make complete sense by the time you go through it a second time. Okay, thank you.